Hello students, today you are going to learn the clustering concepts in the data analytics. We are going to learn this is the roadmap of this lecture. At the end of this lecture, you must know that what is the clustering, why clustering is important in machine learning in data analytics, the types of clustering algorithms in data analytics, which are the real-time examples of the clustering, and which are the applications of the clustering. Look at this picture. This picture shows that the input to the data analytic model is different types of balls. The model will perform something so that you will get the output as the similar objects as one group and the dissimilar objects as another group. So you can see that the clustering is the unsupervised learning method over here. It does not have the label. Based on the characteristic of the input or the objectives, your model will recognize which are the similar objects and which are the dissimilar objects. Based on that, it would perform the clustering. Let's look at the definition of the clustering. The clustering is the most popular technique in unsupervised learning where data is grouped based on the similarity of the data points. Clustering has many real-life applications where it can be used in variety of situations. The basic principle behind the cluster is the assignment of a given set of observations into subgroups or the clusters, such as the observations present in the same cluster possess a degree of similarity. It is the implementation of the human cognitive ability to discern the objects based on their nature. For example, when you go out for the grocery shopping, you easily distinguish between apples and oranges in given set containing both of them. You distinguish these two objects based on the color, the texture, and other sensory information that is processed by your brain. Here, clustering is an emulation of this process so that machines are able to distinguish between the different objects. It is a method of unsupervised learning since there is no external label because it is unsupervised learning. Here there is no labeling. The machine has to learn the features and the patterns all by itself without any given input or output mapping. The algorithm is able to extract inferences from the nature of the data objects and then create the distinct classes of the group, and then appropriately it would group or the collect it together. In the clustering, the algorithm divides the population into the different groups such that each data point is similar to the other data points in the same group and dissimilar to the data points in the other groups on the basis of similarity and the dissimilarity. It then assigns the appropriate subgroup to a particular object. It is also the implementation of the human cognitive ability so that nature-wise you can do the distinguish. Look at this figure. Look at the clustering example over here. The data points that are clustered together are in the group that hold similar data. Then we can further distinguish these clusters through the identification of the three clusters as visualization here. We'll perform the clustering with a basic notion that the data points lie within the range of a cluster center. Then we'll make use of several distance method or the mathematical modeling and techniques for calculating the outliers. Here in the picture, the methods applicable over here are the clustering, and they are the most useful unsupervised methods. Clustering over here is important because it determines the intrinsic grouping among the present unlabeled data. Look at one more picture. You can see that the diagram which shows the clustering system grouped together the similar kind of data in different clusters. Look here, the diamond, stars, and the circles. By applying all those objects, they are in the same cluster. But now I just want to make three clusters based on their characteristic or the physical appearance or their different attributes. By applying the clustering methodology in that, I can find out the similar group and the dissimilar groups of the different objects. That by these two figures, I think that now the concept or what is the clustering, that must be clear to everyone. Let's see further. The question may arise that why clustering? See, clustering is an important technique as it performs the determination of the intrinsic grouping among the unlabeled data set. In clustering, there are no standard criteria. All of it depends on the user and the suitable criteria that satisfy the needs and the requirements. For example, to find the homogeneous groups, one can find the representative through the data reduction and describe their suitable properties. One can also find out the unusual data objects for the outlier detection. The algorithm then makes the assumption that constitutes what similarity of points make the valid assumptions. Let's see which are the clustering algorithms available. Types of clustering algorithms. First one is the partitioning based clustering. See, different reference material refers the different types of clustering algorithm. There are basically 5, but many of the study material tells that there are 6 or the 7 clustering algorithms. In your syllabus, I included only the 5 basic clustering algorithms. First one is a partitioning based clustering. Then it's a hierarchical, then the model based clustering, then the density based clustering, and the fuzzy clustering. See, the clustering, as far as the different types are concerned, each of them are having the different methodologies to do the clustering on a different or different methodologies to apply the clustering method. We'll see each of them in detail. Look at this picture. Clustering in real world. See, identifying the potential customer base. This is what the real-time example of the clustering. Look at this picture. What it indicates. Input to the clustering method is what? The potential customer based on the selling of the product. Now, clustering methodology would identify the customer base group so that the selling product would be done on the identified customer group. It won't give the advertisement to all of the people. It would identify the customer base. It would identify the group of the customer. A particular advertisement for the selling a particular thing would only given to a group of the customer and not all the customers. Let's see further detail the partitioning clustering. The algorithm subdivides the data into the subset of K groups. Over here, the best example of the partitioning clustering is the Kmeans algorithm. In this type of clustering, the algorithm subdivides data into the subset of K groups. These K groups of clusters are to be predefined. That suppose I want a particular input data into the 3 clusters or into the 4 clusters. It divides the data into the clusters by satisfying the two requirements. The first is that each group should consist of at least one point. And the second one is what? Each point must belong to exactly the one group. So this over here, these two things are very much important, and we need to remember that also. If we have given a number of partitions, say k, then the partitioning method will create the initial partitioning based on the value of k. And further, it uses the iterative relocation technique, that is to improve the partitioning by moving objects from one group to another. So here we can say that each partition will present a cluster with the characteristic k less or equal to n, because let's say input data set is of n objects, and you are applying the partitioning method to find out the k partitions. So k is always less or equal to n, and that's why it means over here that it will classify the data into the k groups out of the n objects. Okay, and that would satisfy these two requirements. We'll see from all these 5 basic methods, you are going to learn the K-means clustering of the partitioning clustering method. Let's see, next is the hierarchical clustering. There are two ways to perform the hierarchical clustering. The first approach is the bottom-up approach, and that is also known as the agglomerative approach. The second approach is known as the divisive approach, which moves the hierarchy of the clusters in top-down approach. See, the hierarchical method creates the decomposition into the set of data objects, and you can, as I told, that you can divide it into the two parts, that is bottom-up approach and the top-down approach. A first method, agglomerative approach, is known as the bottom-up approach also because we start with each object forming a separate group. It keeps on merging the objects or the groups that are close to one another. It keeps on doing so until all of the groups are merged into the one, or until the termination condition holds. So that is what the bottom-up approach. As far as the divisive approach is concerned, we start with all the objects in the same cluster. Then in the continuous iteration, a cluster is split up into the smaller clusters, and also it is down until each object in one cluster or the termination condition holds. And hence this particular method is rigid because once a merging or the splitting is done, it can never be undone. So here there are some improvisation or the updation methods are also being applied in order to improve the quality of the hierarchical clustering, as we can perform the careful analysis of the object linkages at each hierarchical partitioning, as well as we can integrate the hierarchical agglomeration by using a hierarchical agglomerative algorithm. So these are the updating method or the updation methods on the hierarchical clustering. You can combine both of this at particular or at certain level. You can go for the bottom-up approach and then you can apply the divisive approach, or you start with the divisive approach and then you are applying the bottom-up approach. So that is what the merging of both of the method into the one method. So there are a lot of updations on the hierarchical clustering method is concerned. The third one is the density-based models. The most popular density-based algorithm is DB-scan method, and which allows a spatial clustering of data with a noise. At this point of time, I need not to explain you what is noise. But DB-scan is a very popular methodology because it applies the clustering with the noise also, and it makes use of two concepts. One is the data reachability and the another concept is data connectivity. This is what the idea over here is, to continue growing the given cluster, that is exceeding as long as the density in the neighborhood threshold. For each data point with a given cluster, the radius of a given cluster has to contain at least number of those data points. See, these are just the overview of these methods. Don't panic if you do not understand these methods, because in detail you are going to learn only the partition based method, but you must know that there are the variety and the very basic conceptual methods for the clustering. The fourth one is the model based clustering method. In this type of clustering technique, the data observed arises from a distribution consisting of a mixture of two or more cluster components. Furthermore, each component cluster has a density function having an associated probability, or it might be the weight in this mixture. A model over here, or the hypothesis for each cluster to find the best fit of a data for a given model is used here. Also, this method locates the clusters by clustering the density function. This method also provides a way to determine the number of clusters that was based on the standard statistics, taking outlier or the noise into account, and therefore it is the robust clustering method. Fourth one is the fuzzy clustering. In this type of clustering, the data points can belong to the more than one cluster. Each component present in the cluster has a membership coefficient that corresponds to a degree of being present in that cluster. And here the fuzzy clustering method is also known as the soft method of clustering. Here some mathematical equations and a mathematical modeling is used in order to apply the fuzzy clustering. Let's look at the applications of clustering. Applications of clustering is very much important because nowadays it is used over here. The first application I've considered over here is the clustering algorithm, which is used for the identification of the cancer cells. Because cancer data set can be identified using the clustering algorithm. How? Because a mix of the data consisting of both the cancerous and the non-cancerous data. The clustering algorithm are able to learn the various features present in the data upon which they produce the resulting cancers. And through the experimentations, we observe that the cancerous data which will be given to us the accurate results when given a model of the unsupervised and the non-linear clustering algorithm. So there are various experimentation which shows that that successfully clustering algorithm has been used in order to identify or recognize the cancer cells. The second one over here I mentioned is the clustering algorithm, which is popularly used in the search engines. When searching for the something which is particular on the Google or any other search engine, we receive a mix of similar results that match to our original query, and sometimes it does not match also. This is what the clustering of the this is what the result of the clustering methods. It groups similar objects in a single cluster and provides that to us. Based on the nearest similar object, the data is assigned to the single clustering, providing a comprehensive set of results to all the users. So, of course, if you look at the search engine, it is not using only the one algorithm. It is using the set of algorithms, the page ranking algorithm, few clustering algorithms, few different platforms. It is not only built upon a single algorithm. So, one of those popular algorithms, one of them is the clustering. The third one is the application of the clustering in the wireless networks. Over here, using the clustering algorithm on the wireless nodes, we are able to save the energy that would be utilized by the wireless sensors. There are various clustering based algorithms in wireless networks are used to improve their energy consumption and optimize the data transmissions. And fourth one I've put here is the clustering for the customer segmentation. One of the most popular application of the clustering in the field of the data analytics is the customer segmentation. Based on the analysis of user base, companies are able to identify the customers who would prove that which are the potential users for the product or the services. Clustering allows them to segment customers into the several clusters based on which they can adopt new strategies to appeal for the new customer base. Now we can practice the clustering concepts, and you can also use the different applications in the real world using the clustering that you can identify and that you can also submit to me. I'll put that particular question in your assignment that you have to find out the clustering methodology in your area or in any other real world applications. As it is the introductory lecture on the clustering, you must be you must know that what is the difference between which are the clustering applications and which are not the clustering applications. Look at this, that how this is not the clustering applications. The supervised classification is not the cluster analysis, because the classification is done on the label data. It is having the class label information. So cluster analysis is not the supervised classification. Or we can also say that it is not the simple segmentation by just dividing the students into the different registration groups by the last name, or by just dividing the students according to their surname. We cannot do the simple segmentation, that is, and we can categorize as this is the clustering. It's not the clustering. Results of a query. Basically, the groupings are a result of the external specification, and from the external specification, if you are asking some query, if you are finding some query and as a result you are getting something, you cannot say that it is the cluster analysis. Graph partitioning is not also the clustering analysis, because there is some mutual relevance and the synergy areas are not the identical. And that's why the graph partitioning is also not the cluster analysis. Now by having the introduction on the clustering, let's go into the detail of the partition based clustering method called as the Kmeans clustering method. The Kmeans clustering method is very popular methodology for the clustering as far as the clustering is concerned. K-means clustering algorithm is computes the centroids. It would calculate the center points from all the population or from all the points, and it iterates until we finds the optimal centroid. It assumes that the number of the clusters are already known. It is also called as the flat clustering algorithm. The number of the clusters identified from the data by the algorithm is represented by K in the K-means. In this particular algorithm, the data points are assigned to a cluster in such a manner that the sum of the squared distance between the data points, again I am repeating, the sum of the squared distance between the data points and the centroid would be minimum. That is what we are finding the centroid first, and from the centroid to the data points we'll find out the squared mean error or the squared distance, and we must make sure that the centroid point and that point must having the minimum distance. And that's why it is to be understood that the less variation within the clusters will lead to more similarity and more similar data points within the same cluster. That is what the concept behind the K-means clustering. Let's go into the detail of this algorithm. We'll first understand the working of the K-means clustering algorithm with the help of these following steps. Step 1. First, we need to specify the number of clusters need to be generated by this algorithm. See, your input to the clustering algorithm is, let's say, 100 data points, and from those 100 data points from a single graph you want 3 clusters as output. Then you must specify the number of clusters that you want as output. So K is defined in the first step as, let's say, 3, K equal to 3 here. Step 2, will randomly select K data points. This is very much important. Initially, the K data points are selected randomly. That is what 3 data points are selected randomly from the whole cluster, from the whole data points. We'll assign each data point to a cluster. Once all these 3 data points are being selected, then each of the data point is selected to a cluster. In simple words, we'll classify the data based on the number of data points. For that, we'll do, or first we'll find out the cluster centroids. As you have selected the 3 different data points, we'll first find out the center point of that cluster. That is what we'll find out the centroid according to the equations given in your reference material, given in the study material. Now we'll keep on iterating these things until we find the optimal centroid, which is the assignment of the data points to the clusters. That is not going to be changed. So here we are supposed to find out the optimal centroid point from the assignment of the data points to the clusters. Because the step 4 is an iterative process of few topics or few points. Yes, we'll iterate this. First, sum of the squared distance. Sum of the squared distance between the data points and the centroid. So whatever the centroid you have calculated in step 3 and the data points which are available, will calculate the data point and the centroid distance. For that we are using the sum of squared distance. Now we have to assign each data point to the cluster, whichever is the closer. Say for example, data point 1, which is from that particular location, you are calculating the centroid, 3 centroids you have selected, or 3 data points you have selected. From the given data point to that centroid, whichever is having the minimum distance, that would be the part, or that would form a cluster, because that data point would be the part of the cluster now. And the third step is we'll compute the centroids again for the clusters by taking the average of all the data points of that cluster. So these are the iterative process. Still, we are not able to find the optimal centroid, or we can say that there won't be the minimum differences between the data points which are going from the one cluster to another cluster. Then we can stop. That is what the points are not changing from cluster to cluster. At that time we can stop that. We completed the K-means clustering, and now we got the output as the 3 clusters and the collection of the data points into those clusters. This is the overall algorithm, K-means algorithm. For the detail, I'll provide you the reference material or the study material on the K-means algorithm, where you will know that how to compute the clusters centroids, and how to calculate the a particular data points and the square distance and all those things. We need to take care while working with the clustering algorithms that it is recommended to standardize the data, because such algorithms use the distance based measurements. Over here the distance is being calculated from the data points to the centroid to determine the similarity between the data points. So here we need to standardize the data. So few of the data is in and their measurement unit is in centimeters, and some of them are having the measurement unit in the meter or the kilometer. So you must do the standardization before applying any of the clustering or any of the data analytic algorithm. Due to the iterative nature of the K-means and the random initialization of the centroids, the K-means may stick in a local optimum. So here we need to take care that it is not going to find out the global optimum. So that would be the problematic, and that's why we need to use the different initialization of the centroids. So initially we have find out the centroid as from a particular group. Then we can change a particular different initialization of those centroid as k equal to 3 or k equal to 2 or k equal to 4 or something like that, and then we can find out a particular proper output of this. And here the K-means follows the expectation and maximization approach to solve the problem. And this expectation step is used to assigning the data points to the closest cluster, and the maximization step is used for the computing the centroid of each cluster. So you have seen that the K-means clustering is divided into 2 parts. One is expectation and another is the maximization. So this is what the K-means algorithm. Let's look at the advantages and the disadvantages and applications of the K-means algorithm. First, over here is the advantages. These are the few of them, because it is very easy to understand and implement the K-means algorithm. You will have lot of platforms available to perform the K-means clustering. I've implemented a K-means clustering approach on a particular iris data set on Veka that I've demonstrated a Veka. At that time I've shown you that how the clustering methodology can be implemented on the Veka. There are different data analytics tools, there are different programming languages. Using that you can implement the K-means clustering, and which is very much easy to implement. Another advantage is what? We can have a large number of variables, then K-means would be faster than the other like hierarchical clustering methods. Third one is on recomputation of the centroids, an instance will change the cluster. And tighter the clusters are formed with the K-means as compared to the hierarchical clustering. So here the comparison is more with the hierarchical clustering, because you can find out the tighter clusters or the cluster which are having a particular boundary in the K-means clustering or the partition based clustering compared to the hierarchical clustering. Disadvantages as far as the K-means is concerned, it is difficult to predict the number of clusters. That is what you have to do the experimentation on your data set. Initially, you must start with the KS1, KS2, sorry, then 3, 4, and so on. Then you must realize that for this particular data, if you will group it into the KS4 or KS5, would be the better clustering approach. So here the experimentation you have to apply, and then you can find out a perfect value of K. The output is strongly impacted by the initial inputs like number of clusters. So that is what the output is totally relationally we can say that it is totally impacted by the number of clusters or the number of or the value of K. The order of data will have strong impact on the final output. Yes, order of the data is having the impact on the output, and it is very sensitive to the rescaling. We have applied the standardization before the clustering, so it is you cannot do the rescaling, or in order to do the rescaling you have to, a lot of efforts are required, and it is not good in doing clustering job if the clusters have the complicated geometric shape. So as far as the data is concerned, as the applications discussed earlier, you can apply onto those, but here when we are talking about the geometric shape, it is not at all clustering job. Okay. So applications of the K-means clustering are concerned, as I told you that the K-means clustering is very much popular. The main goal of the clustering analysis is to get the meaningful intuition from the data with what we are working, and cluster and then predict where different models will be built for the different subgroups. And to fulfill these two goals, K-means clustering is performing well for this applications, for the market segmentation or the document clustering, or as far as the image segmentation is concerned, it is very much and a popular use of the K-means clustering. It is also applicable in the image compression. It is used in the customer segmentation. It is also being used in analyzing the trend on the dynamic data. So these are the real world applications of the K-means clustering. As far as the demonstration is concerned, I've already uploaded the Veka video on YouTube channel. You can just go through that Veka video to find out how to use the K-means clustering method in the Veka, and you can also explore it by yourself, as I've included that how to install the Veka and how to use the Veka in my earlier slides. So thank you. And if you find any difficulties, if you want to go in detail of the clustering, of course you can tell me through, you can send me an email for your difficulties. I will definitely guide you. These are the references I've used towards data science and analytics Vidya, dataflair, tutorials point, and Geeks for Geeks. Reference material in order to make this video, in order to make this particular slides. Thank you, students. Thank you so much.